All right, snow leopards, welcome to day 7, chemical reactions. This is your final day. We're doing a summary. Your goal today is to continue to figure out the energy piece. We're going to determine where that energy comes from. Then you're going to be putting the entire unit together. By the end of the period, you should have your doodle sheet completely done up through Y, and you should also have it revised as needed. Then you're going to be applying what you've learned to coma patients. All right, so what about the energy? Here we have a chemical reaction. Is there energy present? What evidence is there of energy? So looking at this picture here, what is our evidence of energy? Here we have a familiar equation, or it should be. You've got your ethanol on this side, right? And when that gets ignited, that combines with the oxygen in the air. And then these molecules, the individual atoms, they get rearranged into carbon dioxide and water, or water vapor. So we know that when you have, we've been rearranging these atoms, but how does this rearrangement of atoms actually give us energy? So let's track the energy. Think about that burning of ethanol again. But this time focus on what happened with the energy. What evidence did you see of energy in the actual system? Go ahead and write down what happened with energy before, during, and after the reaction in Doodle V. And I understand that you did use your vocab to try and answer that yesterday or in day 6, so you may have an answer there. But if not, go ahead and put something in right now. All right. So hopefully you've written that there is energy, and we know there's energy. We've also talked about the conservation of energy. And just remind yourself, what is that conservation of energy? Remember, energy cannot be created or destroyed. That's a key thing. And that also relates back to similarly to matter, right? That rule of matter, that matter cannot be created or destroyed. Well, energy can't either. So, where does the energy we can see during this reaction come from? Add that into Doodlebox V as well, if you haven't already. Where does the energy come from? What is the actual source for the energy? Don't overthink it. Okay, well, we know that there are calories in food. That means there's energy in food. So, does it make sense? There is energy in ethanol. Sure, but we can't see it. So let's look at another system where we cannot see the energy before or after, but we do see evidence of energy during. So again, you look at the ethanol, it's sitting in a container, right? And you think, I don't see any energy, but yet it has it. So what kind of energy does it have? Well, to help you think about that, let's look at the following example. This example talks about the energy of a bowling ball. Do you think there is any energy in this ball here? So is there any energy here? What do you think? Well, what if we push the ball? That's movement. Well, we know movement is energy, right? That's kinetic energy. So now it's down here at the base of the hill. Is there any energy in the ball here? What do you think? Let's go back to our laws of energy. If energy is conserved, where was it before? Remember, energy is not cannot be created or destroyed. It gets conserved. So where was it before? Well, if we put our bowling ball back at the top of the hill, that means it had a potential energy, and the potential energy at the top of the hill is quite high. We know that because of gravity, right? Then if we push it, boop, we now know at the base of the hill, the potential energy for it is a bit low, okay? And then, of course, just graphing these energies, we know that it went from potential energy to kinetic energy, and then now it's sitting, so it's back at potential energy again. Some of this stuff may remind you of what you did for the helix cup back in middle school. All right, so that means we know that that energy gets transformed into a different kind of energy. This is the key connecting concept for the bowling ball. This is not the exact thing that happened with your ethanol, but we do know that your energy in the ethanol was transformed. So potential energy is invisible. We don't see it, right? You got the ethanol, it's sitting in the container. You don't see it. You can pour it into the little petri dish. We don't see it. But yet, once the ethanol is lit, we can see that flames coming up, and we know that transformation is going on. All right, so what's going on with energy? How does that bowling ball help us understand what might be happening with energy in burning ethanol? So considering our ethanol reaction, which substances, so which things, do you think have high potential energy? Provide a reason for your answer in Doodle W. So what substances do you think have high potential energy? Think about it in terms of the molecule. Think about it in terms of substances, items, foods, things you know about. What might have high potential energy? All right, now that you have that answer in, let's go to your next one. How could you graph energy? Okay, first let's take a moment to get familiar with this graph. On the Y, we've got molecular energy, and keep in mind the arrow is going up, so this is your energy is increasing in this direction. On your X, you've got time, and that means your energy is increasing in this direction. So if you're graphing your energy here, if this is where we're starting at, what happens to the potential molecular energy in the molecules as we move from reactants to products over time? So you remember your ethanol is a reactant, and what's going to happen to it as it goes, as this experiment takes place? Do you think its molecular energy as the experiment takes place is going to increase? Do you think it's going to stay the same? Or do you think it's going to decrease? Do you think what's going to happen to that potential energy? That's key. We're actually graphing the potential energy. What's going to happen? Go ahead and put in your answer now, and then put me on pause. Put in your answer, what you think. Okay. Oh, so hopefully you still have that in. You're not just playing me continuously because you just love the sound of my voice. All right, so what happened? Wow, the potential energy is going to decrease, right, as energy gets released as the atoms are rearranged. So that chemical reaction taking place releases a tremendous amount of energy, which means you are changing the potential energy of that matter. So you're rearranging the matter, and that changes the potential energy of it as it goes from being a reactant to we get to our other side, the product side. All right, so what have we figured out now? Our driving questions were, why do living things need food? And how do we get the matter and energy we need from food? Go back through your doodle sheet, and I want you to compile all of the model ideas into one place in Doodle Y. So put all model ideas to one place in Doodle Y. And I want you to also think about those finches and moose and use your model to answer the driving questions as completely as you can. Why do living things need food? And how do we get the matter and energy we need from food? Your final piece. It's the challenge question. Here we have a coma patient, Aaron Cohen. You can actually see his YouTube videos when he went into a coma due to a bacterial infection. His family members did video some of his state in the coma, and they put it on YouTube. It has a happy ending. He did come out of it. But here's the thing. So he's got this feeding tube, and that's put into his nose, and it's necessary for him to survive. Every day it delivers food, but however, his mass is never changing. So his actual body mass doesn't really change. The nurses who take care of him have to change diapers that contain poop and pee multiple times each day. So use your model of chemical reactions in living things to explain what is going on here. Why does his mass never change, despite the fact that the feeding tube is inserted into him and he is being fed food? And how is it that he continues to poop and pee multiple times a day? Use everything you've learned in the model to answer that question. Then put your names on the paper and turn it into me. You're also going to turn in this entire unit to me for your notebook. You've completed it. Well done. Next week, or if not within the next time we meet, I should say, you will start a biosynthesis unit. So we're going to go even deeper. However, there will be a test on this, and you'll take the test in a few days' time, but I'm going to give you time to review and process some of this information before you do the test. Okay, well done, snow leopards.